Okay, that's enough. Anyone have had any idea this problem? How to solve it? Why, guys, you don't speak? So there could be multiple solutions for any problem.
Is this is something related to a graph problem?
What did you say again?
Is this is something related to a graph problem?
Yes, actually, this is a graph problem. Yes. Mm, yes. So let's explain the problem. So we are given some graph. Actually, this is a graph. We are giving n cities and m roads between them. So we will connect cities by road. Okay. And then we want to construct new roads. Just add new roads between any two cities to make. We want to add the minimum roads to make all the cities connected to each other. Okay, so all the cities connected to each other means that we can reach from any city to any other city. Okay, um, let's draw something. For example, all of these are connected graphs. Okay. Uh, a connected a connected city will be something like this. So let's make the nodes are the cities and the edges are the roads. Okay, so we have city 1 connected to city 2, and here another city, and here another city. It's not a tree, so there could be something like this. Okay. Uh, Anything. Okay, so these cities are obviously connected. Why? Because you can reach from any city to any other city. Okay. um, but for example, these two cities are connected, but these two, so this graph and this graph is not connected. So any city from here, any city from here to any city from here won't be connected. So how to connect them? How to add road to connect any city from here to any city from here? Actually, we want just one route to connect any city from here to here. Just add from any node here to any node here. That's it. Okay, it could be this or anything. So we'll observe that the solution will only involve that we count. So this is called a connected city in the terms of graphs. This is called a connected component. Connected component is a component of nodes where we can reach from any vertex to any other vertex. Okay. So what we will do in this problem is only to count um, the number of connected components. So here we have three connected components, right? And we cannot reach from any city to any other city, from any connected component to any other connected component without adding roads, right? So for this connected component, we can reach any city in it, and for this connected component, we can reach any city in it. So how to? Where is my spotlight? Okay. How to add the minimum number of roads to make all these cities connected? Actually, we can just add two roads. We add from any connected component to any other connected component. So we add from here to here, and we can add from here to here. That's it. So we added two roads to just make all the cities connected to each other. Okay. So the solution will go something like this. We will do a DFS. So just count DFS from any node, and then go for all nodes that we can reach. Okay, so if we DFS from here, then we'll reach all these nodes. Okay, and then DFS from here, and then we'll have reached all of these nodes. Then DFS from here. Then so we have made three DFSs, right? So we know now that we have three connected components. So the answer will only be that we will add only two roads. Okay, we'll add only. So if we have, for example, n connected components, then we will add n minus one routes from the first city to all the other cities. Uh, let's let's make the thing easier. So now that we have three connected components, we don't have to add roads from this to this and from this to this. We can make something easier. We could uh, just hold one component, one connect component, and that's it. And then add a road from it to all the other components. Okay, so add from here to here, then from here to here. That's it. And if I have another connected component here, then I'll add from that same node to here. So just to make it easier to code, we'll just know any node. We'll just store any node from any connect component, okay, and then add a road from the first connect component to all the other connect components, okay, and now we have a fully connected city. Okay, another connect component here. We'll add from that same node to here, and that's it. Okay. Any question before I go to code? Any question in this drawing before I jump to code?
In the problem, did they mention anywhere that we'll be given like three connected components or four connected components? Anything like they have mentioned it?
Okay, let's go back to the problem and see what are they mentioning.
Mhm.
Okay, so here the problem says that we are given n cities and m roads between them. Okay, so we are given bunch of cities and bunch of roads, and we just want to add the minimum number of roads to make all of them connected, right? So what does this line means? Your task is to find out the minimum number of roads required to make this connected. It means that we have some connect components that are not connected, right? So if all the graph is just one connect component, then we won't add any roads. But we will add roads because there are some components that's not connected to others, right? So this is an observation just from us. So I am saying that the meaning of this that if you go deep in the graph, we will find that it's a bunch of connected components. Any graph is something like this. Okay, so any graph is some connected components. It could be one connected component, or two, or three. So any tree, for example, like the last problem, is actually one connected component because you can reach from any node to any node. Okay, so that's it. Since I'm given bunch of trees and bunch of roads, then I'll have multiple from zero to n connect components. So if I'm not given any edge between any nodes, so if I'm given n equals to 1 million, for example, and m equals to 0, then I'll have something like this. This is the first city, this is the second city, the third city, fourth city, fifth city, and there is no any roads between them. So actually now we have 5 connected components because I can reach from any city to itself only. So this city to itself, this city to itself, this city to itself. So now I have 5 connect components. Whenever I add any edge to 2 connect components, then I decrease the number of connect components by 1. Okay. So now I'm saying that I'll count the number of connected components for this graph, and then the answer will be the number of them minus 1, and then connect them the way I said. Okay. Is it clear now or what?
Yeah. So let's say you have drawn like five cities, right? In the previous example.
Uh, I draw like what? I didn't hear you correctly.
So you can you draw like some four nodes which are not connected?
okay, I made something now. So here I have 5 nodes, 4 nodes,
Okay.
for example, and
o-
they are not connected. Okay, so here I have 4 connected components. That's it.
Okay.
Okay.
So as you said, like in the previous example, so we'll take one node which will be connected to another node, one connected component connected to another component.
Yes, and
Okay.
that's it. Okay,
Yeah.
so we'll just fix. For example, we fix this node,
Okay.
and then connect it to all the other connect components. So we'll just add here, here, here. So we'll have 3 rows. The number of connect components minus 1. That's it.
Okay.
Okay.
Yeah. Makes sense.
Okay, let's jump to code. I'll make the code smaller. Okay. Let's take the input first and then make everything. So since we have just normal graphs and very big graphs until the number of nodes until 10 power 5, number of edges until 2 times 10 power 5, then we'll have an adjacency list representing the graph. Okay. And m is the highest number we could get. Okay. Okay, now we want to take the edges, so we'll make well m minus minus into ab. So for each line, we are given only two cities, and then we'll connect them by one road. Okay. So add push back B push back A. So that's it. We have just made the graph now. So now it comes to actually getting the connected components. So we'll make a simple DFS to discover the connected components. First, for the DFS, we'll make a Boolean visited array to determine if a node is visited in the DFS or not. Car means the current node we are standing at. So we will only go to the DFS if not v of car. So if current is not visited, then we'll continue the DFS and we'll make it visited because we have visited it now. Okay, and then just we'll go DFS through all the adjacent nodes to current. For int x match of car DFS x. So that's our DFS function. We'll go through all nodes. But now we want to call the DFS function in a way that we will store, for every new DFS, we will store the node that's representing this component, okay? So as I said, I'll have multiple connect components and I'll have one node to represent this connect component. And then I'll just connect the first node of the representer of the first connect component to all the other representers, okay? I'll have a vector here called the naming is too hard. Vector. Okay, just call representers. So vector called representers, which will store the representer for every connected component. Okay. So now we will pass. We'll go from int I equals 1 until I is more than or equal n. We'll go through all nodes, and then if I didn't visit this node, then I'll do a DFS starting from it. Okay, so if I didn't visit this node, then I'll do a DFS starting from it, and then I'll add this node to the representers. Okay. presenters presenters pushback I. Okay. So whenever I didn't visit, I'm not visiting, I didn't visit a node, then I'll add it to the presenters vector, and then I'll have a bunch of representers here that represents the connect component. Okay. So what should be the output? The output should be the number of roads and then describing each road. And the size of this vector array is actually the number of connected components, right? So the number of rows that we will add will be this size minus one. Representers dot size minus one. This is the number of rows that we will add, and the actual rows that we will add will be, as I said, I take the first element, so the first representer of this vector array, and then connect it with all the other components. Okay, so I'll start from y equals to 1 smaller than. So I start from the second element, not the first element, and then for each element of these elements, connect the first element to it. Okay, so I just print representers of 0. That's it. So representers of 0 is the first element or the first component. I'll connect it with all the other connected components, and here we have our roads. Okay, is there anything wrong here? Let's try this.
In the furries, should we check whether already we visited or not in the DFS?
Um, I should check what?
So in the DFS method, so when we are
Yes.
looking through all the adjacent nodes, should we check whether already it is visited or not?
Yes, this won't make any difference here because if I'm calling the DFS of a node, it is
Mm-hmm.
actually checking if it's not visited or not. So if it's not visited, it will continue. If it's visited, so it will not continue. So the DFS function only works if the node is not visited. Okay.
Okay, thank you.
Okay. So now I tried the code and it printed 1.3. And 1.3, one is the let's take the example. One is the representer for the first component here, and it's connected to 3. So it shouldn't. It doesn't have to be the same like the output given here. Okay. So here it connects 2 with 3, but I'm connecting 1 with 3. Okay. So here the answer should be correct. Let's try to submit this. Any question in this code? Uh,
I
Anyone
have
wants?
a question over here. So
Yes.
here in the main loop, you're sending to that DFS and you're incrementing that, pushing back to that representers. But if that node is already visited, it will that will already be pushed into the representers, right? You're getting to know whether it is visited or not once you're going into that DFS. But before itself, it is pushing over here and coming back. For example,
I didn't get you quite well. So okay, I'll just explain this loop and then hear your question because I didn't understand you quite well. So here, this loop, what it makes is that for any node, it first checks if it's not visited or not. Okay, so if it's visited, so it will not add anything. If it's not visited, then it will add it to the representers array, then make a DFS from it. So after making the DFS from this node, it will make a whole bunch of other nodes not actually visited. So we will not add the representers, any node to the representers after we have done this DFS. Okay. So what's your question now?
okay, got it, got it.
Got it?
Yeah.
Okay. Okay, let's submit it. Where's the submit button? Okay, let's submit. Okay. Um, Let me check if this link is available for you or not. Can anyone open this link and say if it's available for him or not? I sent it in the chat. If he can see the submission or not.
Can you please explain that how you are taking the input part on that while loop one more time, please?
On the while loop.
Yeah.
Okay, let's go. Okay, so on the while loop here, I'm just so while m minus minus means I'm passing m times. Okay, so m is representing the number of rods I'm given. So I'm given m rods. So I'm loop m times, and I'm not caring about m being decreased. So now m minus minus is being decreased until it reaches to zero, and then I'm taking two nodes a and b, which representing the two cities, and then I'll just want to connect it to each other. So to connect a and b, I'll add B to the adjacency list of A. So that means that B is adjacent to A, and then add A to the adjacency list of B. That means that A is adjacent to B. Okay, that's it. Uh, did you get your answer, or there is something else
Yeah, can you just
you
show
want to
me the
understand?
sample input, whatever you have to in the Visual Studio?
Okay.
I mean, whatever the code you have executed, you can show the sample.
Uh, what is what? What is that? I'm getting to you a sample input now.
Okay.
So let's make a sample input myself. Okay, so let's say I have six nodes
Okay.
and three rows. Okay, and then I want to say that one is connected to two, and three is connected to four, and five is connected to six. So this is the input. This input says that one is connected to two, three to four, five to six,
Okay.
and then it outputs something. Okay, so what does that do is we have three components here, and it will add two to the adjacency list of one, and one to the adjacency list of two, and four and three, and six and five, that way. So we'll have three components, and the answer here is two, because we added two rows to connect these three components. Did you get it now?
Yes, it's clear. Thank you.
Okay. So you are saying that the link is not available for you?
Yeah, not able to see that. It's
Okay, let me check this. Yes, the submission seems to be not working, but it's not a problem. I'll send you the code in paste bin, for example. Okay, here is the link to the submission. Make sure to know that this submission is to this problem, because after getting many submissions, after sending many submissions from this site, you won't be able to know which is for which. Okay, let's move to another problem. Okay, let's go to this problem. Okay, take 3 minutes, think about it, and discuss it with me. Okay.
Can show the problem once. I think we are seeing your Visual Studio Code.
You are what?
Yeah,
I didn't hear you.
so we are not.
What did you say?
Okay, so increasing array is the problem.
Sorry, I didn't hear you. What did you say again?
Increasing array is the problem which we are going to solve.
Yes, I've actually sent you the question link.
Okay.
Here in the chat. Okay, so look at the chat every time. Okay, every once in a while.